All right, everybody, welcome to the video on geometric sequence. We're going to talk about all about sequences in the next coming weeks. First one is the geometric. So some questions you should be asking yourself is, what is a geometric sequence? How can you tell a geometric sequence from other types of sequences? How can you find the common ratio? What is the explicit formula for a geometric sequence, and what shape does the graph of a geometric sequence make? Those are all important questions to ask. By the end of the video, hopefully you'll be able to determine if a sequence is geometric or not, and find a recursive formula for a geometric sequence. Ooh, that sounds probably a lot kind of like nonsense, but hopefully by the end of the video, it'll make sense. So here we go. So first, when I say sequence, I just mean it's like a series of numbers. Usually in some sort of pattern. So a sequence would just be like something that's like separated by a comma, like 1, 2, 3, 4 would be a sequence. It's just like a series of numbers, right? And a lot of times, like this would be another one, like 2, 4, 6, 8, right? Or it could be like 1, 3, 9, 2. Like it doesn't have to be anything special. It's just a sequence of numbers. Those would all be examples of sequences. Okay? Now, a geometric sequence is a series of numbers that has a common ratio, meaning to get from one number to the other number, you multiply by like the same thing. So, for example, this sequence, 2, 4, 8, 16, 32. If you're looking through the pattern, you would notice that from each number, to get from the first to the second, you multiply by 2. To get to a second and a third, you multiply by 2. Right? To get to any of the following numbers, you multiply by 2. That's how the sequence is made. And this is a common form for a geometric sequence. Anything that's the next number is being made by multiplying the previous number by something, that is when it's a geometric sequence, when that number is multiplied by the same thing. A real life example would be like, say you're sick and you get 2 people sick, right? And those 2 people each get 2 people sick. So here you would have a total of 4 people, right? And then those 4 people get 2 people sick. You see how each time you're getting multiplied by 2, right? That would be an example of a geometric sequence. The common ratio is the most important part of a geometric sequence, and that's how much each number is being multiplied by that. We call it the common ratio. To find the common ratio, all you do is you take the following numbers. So say it's like the third term of the sequence, right? This would be like in this sequence 1, 4, 16, and 64. To find the common ratio, you just take for example, the second number and divide it by the first, right? Because in order to get from the second to the first, you multiply. So to find the common ratio, you would divide. So 4 divided by 1 is 4. And you could do that with any term in the sequence. 16 divided by 4, right? So that's just the previous term, is 4, right? And 64 divided by 16, the previous term, is also 4. So in order to find the common ratio, just take any of the following numbers, like if it's the second term, divide it by the first term. If it's the third term, divide it by the second term. Just divide it from the previous term. So here we go. Let's find the ratio. So 2, 4, 8, 16. That's the one we just did. But here we go. In order to find the common ratio, which we call R, so R is the common ratio. That's the notation we use. R equals common ratio. That's the letter that we use to say that, right? So let's say we're going to figure out what R is. So say you had 2, 4, 8, 16. Well, you take 4 divided by 2, you get 2. That's the second term divided by the first term, right? So a notation that you might use would be like the second term divided by the first term, which we'll get into kind of later. But anyway, we won't worry about that. So 4 divided by 2. Or I could take the third term and divide it by the second term, right? 8 divided by 4 is also 2. And lastly, 16 divided by 8, the fourth term divided by the third term, is also 2. So you see how each of those, when you divide them, is 2. So the common ratio is 2. Now this next one. Take 3 divided by 1, you get 3. Take 9 divided by 3, you also get 3. You take 27 divided by 3, also get 3. So R is a common ratio of 3. Now 25. Now 5 divided by 25. A lot of kids want to tell me this is 5, but it's not. 5's on the bottom, right? So this is 1/5, right? And then I take 1 and divide it by 5, and what do I get? 1/5. So the common ratio in this case would be 1/5. Doesn't just have to be a whole number, it could be a fraction. Okay, so for this one, we're going to determine if the following sequence is geometric or not. If it is geometric, we're going to state the common ratio. So here we go. The way that you would figure out, well, if it's geometric, it'll have a common ratio. If it's not geometric, they won't have a common ratio. So let's define 1 divided by -1 equals -1. That's the second term divided by the first. And 4 divided by 1 is 4, right? But that's not -1, so it's not a common ratio, right? The second term divided by the first term is -1. But the third term divided by the second term is 4. So, no, it's not geometric. Alright, we're going to determine if the following sequence is geometric or not geometric. If it is geometric, we're going to state the common ratio. Alright, so let's divide the second term divided by the first term. Right, second term divided by the first term is -5 over 1, which equals -5. And the third term divided by the second term. The third term divided by the second term is also -5. So yes, it is geometric and its common ratio is -5. Okay. Now there is quite a bit of notation when it comes to sequences. We're going to talk a little bit about that. First of all, the letter N always represents the number of terms. Whenever you see M, it's always going to say the number of terms, and oftentimes we're going to use this to describe like a sequence that we don't know how many terms it has, or maybe it has infinite terms. N is kind of like the variable. It's like a placeholder that we use. It's kind of like X, but instead of that we use a lot of times in the equations, we use N for sequences. And also with sequences, we use subscripts to represent the term number. Okay, so for example, this term, g of n equals 2, 4, 6, 8. So what this means is g of n, we're calling our sequence g, and we're saying like this n could be the first term, it could be the second term. It just represents like a sequence of any terms. And so if we wanted to find the first term, well, g1 would be, okay, it's the first term of the sequence that has n terms, right? So g of 1 would be the first term. So what would be the first term? It would be 2. G of 2 is the second term. Well, the second term's right there, right? It's 4. G of 3 means the third term, which is 6, and G of 4 would be the fourth term, which is 8. So we use these little subscripts to specify the term, and this here is like a placeholder. It's like whatever term that you want can go there. Okay? Now this next formula is really, really important. So a lot of times we don't want to state sequences like a series of numbers. We want to state it as like a formula that can tell us essentially what term you need. So like, for example, this formula can give us, instead of it being like having to write like 2, 4, 8, 16, we can write like some formula and then call like a term that we want. So like, what if we wanted to know like the 18th term of this formula? We wouldn't want to have to keep on multiplying by 2. we would want like an easy formula to be able to tell the number of terms, or like the 12th term or the 10th term, without having to multiply by the common ratio 10 times. So for that, we use this recursive formula, right? And so make sure you know this formula. It's going to use notation that looks kind of confusing as well, but let me just explain it. So we call the sequence, we're going to call it g of n because it's a geometric sequence. Okay, so remember, n just means it could be however many terms that the sequence has, and we can use it to find this formula to find any term. We can find the 7th term, the 9th term, the 10th form. This formula right here is going to classify the sequence and help us find its terms. So what you do is, in order to find the formula, you take whatever the first term of the formula is. So in the example, this would be 2, right? That would be 2. This would be like, say this was like g of n, right? G of 1 would be 2, right? And then r is the common ratio. So for example, for this one, it's 2 as well, because it's 2 times 2, 4 times 2, right? To get to each previous term, you have to multiply by 2. So r is the common ratio. So if I wanted to write this formula, it would be, if I was doing this equation here, it would be 0.0, why did I do 0.02? It would be 2, right? And then it's raised to the n minus 1, right? So if I wanted to write this as a explicit formula, I don't know why I'm saying recursive, it would be 2 times 2n minus 1. 2 is the first term, and it's also the common ratio. So just remember this formula here. So here we go, let's practice this. So determine if the sequence is geometric and find the common ratio. So if it's geometric, then it'll have a common ratio. So let's divide the second by the first. Let's divide each term by its previous term and make sure that it is the same. So 2 divided by 1 is 2. 4 divided by 2 is 2. And 8 divided by 4 is 2. Bam. So the common ratio is 2. Now the explicit formula, we need the first term. First term is a1, right? So we're going to remember, we're always going to call it g of n. And it's going to equal the first term, which is 1 in this case. So it's going to be 1. That's the first term, right? Times the common ratio, which we just found is 2. And we're going to raise it to the n minus 1 power. And that is our recursive formula. Now check it out. We can find the 10th term, right? All that means is, remember, n could be any term. N could be the 3rd term, the 4th term. This could tell us any term. So if they wanted the 10th term of this formula, you would just plug in 10. Right? And that just means replace the n with 10. So we're going to go to Desmos here. Open in Safari. And the way that you're going to do this is you're going to say, okay, G, and here's our subscript button right here. Right? You're going to go N. And we're going to have to hit the subscript again. Okay. So if you're on your Chromebook, you can just hit Shift and the minus sign. And that's what it'll make the subscript. Okay, and it was equal to, we don't need the 1. You can put the 1 if you want. Maybe I will for this one, but you don't have to put the 1. You would do 1, parentheses, 2, and then erase it. And you don't want the second power. Make sure you have parentheses in your power as well. And it's n minus 1. It's actually going to graph it for you. And then if we wanted the 10th term, we're just going to plug in 10. And we're going to say, what does that equal? Oh, no. You're just going to say, sorry, n equals 10. Right? Okay, if n equals 10, then the function is 1512. So that means that the function's 10th term is 512. Pretty cool. So if you wanted the 50th term, you would go n equals 33. I don't know why I said 50th. If you wanted the 50th, you would go 50. But if you wanted a 33 term, like I don't know why I picked 33, but that would be the 33rd term. So the 50th term is 5.63 times 10 to the 14. That's a pretty freaking big number. You guys get the point. So here we go. The common ratio, the 10th term, that's what they asked us for. So we're going to set n equals to 10. That's 512. All right. So determine if the sequence is geometric, and we're going to find the common ratio. So remember, if it's geometric, that means when you divide, you get the same thing. So 5 divided by 1 is 5. 25 divided by 5 is 5. So yeah, it's geometric. Its common ratio is 5. Now the explicit formula, we need the first term. So we're going to say g of n, our geometric sequence. Its first term is 1. Once again, won't always be, right? That's the first part. First term is 1. And then you multiply by the common ratio, which is 5, and raise it to the n minus 1 power. Plug that in to Desmos. You're going to say, remember, g, and you're going to go subscript of n. You're going to say that's equal to 1 times 2 to the, make sure you do parentheses, n minus 1 power. And then they want the fourth term in this case. So you're going to say, hey, n equals 4. And it's going to tell you g of n equals 8. So the fourth term in this sequence is 8. Bam. All right, determine if it's geometric and find the common ratio. So here we go. 256 and 128. So you're going to take the second term, 128, and divide it by 256. 128 divided by 256. 256 divided by 128 is 2. So 128 divided by 256 is 1/2. And if I take 64 and I divide it by 128, 64 times 2 is 128, which means 64 divided by 128 is 1/2. So the common ratio looks like, well, we have to check 32 and 64, make sure. And sure enough, 32 divided by 64 is 1/2. Since it's has the same term each term, you're going to say, yeah, common ratio is 1/2. To write the explicit term, you need the first term. The explicit formula, you need the first term. The first term is 256. So it's going to be g of n, our geometric series with n terms, equals 256 times our explicit form, our common ratio, n minus 1. There you go. And they want the 8th term. So to get the 8th term, you're going to go to Safari, Desmos. You're going to say g subscript of n. And you're going to say that equals, in this case, it wasn't 1. It was, the first term was, I already forgot, 256, parentheses, and then you're going to go 1 divided by 2 is 1/2 was our common ratio. 1/2. And then make sure when you raise it, not 2, to the power, you go parentheses n minus 1. And they want the fourth term. So you're going to say n equals 4. What's the fourth term? 32. The fourth term is 32. So here we go. Oh, they want the 8th term. Well, that's not a big deal. The 8th term, that's when n equals 8. That's 2. Interesting. That's 2. Okay. Now, if they wanted to generate the first 4 terms of this sequence, we could still use the scientific calculator to do that too. So, I'll do one of these. I won't do all of them. But to generate, this is how you do it. So, g of n equals 2 times 3 to the x minus 1. It shouldn't be x minus 1, guys, because there's an n right here. This should be an n minus 1. Right, so here we go. G of n, I'm just going to change this. G of n is equal to 2 times, so I'm going to say 2 times 3, the power button, I guess I could just use the squared button and go backwards. Make sure you do the parentheses. It's 3 to the n minus 1. Right? That's the term they want us to use. Yep. And then they want the first 4 terms. So you would say, first 4 terms, you would say, well, you're going to say n equals 1. That's the first term. My first term is 2. Then I'd write down 2. Right? The way that I would write that down is I would say, on my paper, I would say g of 1 equals 2. That's my first term, right? Because we're calling my series g. Okay, and then on the second term, I would say, okay, n equals 2. And then on my paper, I would say g of 2 equals, it says 6, equals 6. All right? And then they want the third term. So you could say the third term. If I were to find the third term, I could literally just slider this if I wanted to. All right? I could go to the third term. I could say, what's the third term? Jeez. Having a hard time with the iPad, but third term's 18. So I would say on my paper, I would say g, and then I would go subscript on my paper 3 equals, it said 3, or you could literally just type in 3 if you wanted to, like that, 3. Oh yeah, but the third term is 18. That's my third term. And then the fourth term, I would say g of 4, g sub 4 is how I would say that out loud. G sub 4, or the fourth term of my geometric sequence, is 18. There we go. And those are all kind of like that. And that'll be it for this video.